So hello everyone, welcome back to Consumer Theory Part 2. This is Microeconomics Semester 3 for Delhi University. So let's begin with our Part 2. Okay, so now today the major thing we'll have to do is the types of utility functions in consumer theory. But before that, there are some minor concepts we need to know about them. So let's begin. So the very first thing would be uh, commodity can be of three types. We have economic goods, we have economic bads, and we have economic neutrals. Okay, so to understand this, suppose now there's a basic thing that no good is an economic good forever, and no good is an economic bad forever, and neutral also. For example, there's a consumer, Mr. A. He loves to consume ice creams after dinner. So he has a basic appetite of 2 scoops of ice cream. Okay, 2 scoops of ice cream. But let us suppose that we wish to give him 4 scoops of ice cream one day after dinner. He will take it. He will be very happy. Like he loves to consume ice cream. So until 4 scoops, he is getting a kind of positive utility from consumption of ice cream. But let us say the next day after dinner, we try to give him 6 scoops. Today he also is very happy. Next day we try to give him 8 scoops. But now he is not even wanting to consume even 1 scoop. He says, I don't want it. I'm done. So in this case, now at this point of time, ice cream scoop has become an economic bad for him. He is getting a kind of negative utility from consumption of ice cream. So from this example, we get to know that until 6 scoops, for example, the ice cream scoop is an economic good for him, and after that, it becomes an economic bad. So from this basic analysis, we get to know that economic goods have a positive utility, marginal utility, economic bads have a negative marginal utility, and economic neutrals have zero marginal utility. Okay, let's move further. Now let's see some cases. Let me draw a graph first. Okay, now I will be denoting economic good by G and economic bad by B. Okay, so let us say that good one is an economic good, and on the y-axis we have economic bad. Economic bad. Okay, now this is a basic technique to how to draw the ICs there. First of all, we see that which point on in this space is the worst point for a consumer. So for example, G economic good we have on x-axis. So the worst point would be the least of economic good, and economic bad is on the y-axis. The worst point would be the maximum of economic bad. So this one. Okay. So in this case, the IC would be like this. So the curve would be facing the worst point. That is this in this case. Okay. Let us take one more example. Let's say we have both economic goods in the axis. Okay, Now, what is the worst point for the consumer in this space? Both are economic goods. So the worst point would be where he is consuming the least of both goods, that is this one, very close to 0, 0, and the curve would be facing this point. The IC would be somewhat like this. Okay, and this we can see is an upward sloping IC. It's positively sloped, and this turns out to be a negatively sloped. Okay, let's see some more cases. Let's see some more cases. Now let's take economic good here, economic bad here. Once again, what is the worst case in this, worst point for a consumer in this space? That would be the least of economic good, which is somewhat here, and the maximum of economic bad, that would be here. This is the worst point, and the curve would be facing this. We will be getting this one. Okay. So this would be it. It's not resembling anyone. You can check. Okay. This is another IC. So let's take one more case with an economic neutral. So that would be completing this section. Let's take neutral on this and economic good on this case. Okay. Now what's the worst possible case? Now we know that economic neutral gives zero marginal utility. So either he consumes too much of neutral or either he consumes too less of neutral, it won't matter. Okay. So what's the worst possible case would be that he gets least of economic good and anywhere of economic neutral. So since this is an economic neutral, our IC would be a straight line, a vertical line in this case, to be precise. Okay, so we can analyze here that whatever the consumption of good X, that is economic good, the consumer is having, it is not affected by the consumption of economic neutral, and direction of the IC would be rightwards. The utility is increasing as the economic good consumption is increasing, but there is no change in utility from economic neutral. We say, let's say he is consuming this point first at X, and now he increases economic neutral consumption, but now also is on the same IC. So utility has not changed. Utility has not changed. Okay. So you need to practice some more cases by yourself by making neutrals and goods and economic bads on these axes and trying out the ICs. If you have any doubt, do add in the comment section. I would try to answer. Okay. Okay. Now let us begin with the utility functions. Okay. So the very first function that we have to study would be Cobb-Douglas utility, and the general form here is u, the function of good x and good y, x raised to the power alpha and y raised to the power beta. Okay. Now first of all, there would be a specific format we would follow for studying utility functions. That would be the general form we have to write. We will study what is the MRS, then we will see the equilibrium conditions and the ICs, of course. So what's the MRS? We have proved earlier in the first class. If you haven't watched it yet, do watch it. The slope of the IC, that is the MRS, equals negative of MUX upon MUY. We derivate it, we use partial derivatives, and we would be getting alpha x to the power alpha minus 1 y as it is whole upon beta x to the power alpha as it is y to the power beta minus 1. and this equals to be negative of alpha upon beta, okay, y upon x. Now we can see that it is of the form y by x, therefore we would be getting convex IC. Okay, we would be getting a convex IC. Let's draw it. And our IC would be perfect rectangular hyperbola. And the bundles can be here or here, here, anywhere they can be. This is good x, this is good y. Okay, now moving ahead, we see what is the optimal choice in this utility function. What's the optimal choice? Now to operate for the optimal choice, we have to understand that you would be given with some conditions. What is the price of good one, P1, P2, and what is the money income of the consumer. Okay, and from this we can write the budget set, that would be P1x plus P2y less than equal to 1. The expenditure of the consumer, this is expenditure on good x, expenditure on good y, this must be less than or equal to the money income of the consumer. Okay, this is the expenditure side, this is the income. And what is the budget line? The budget line would make this an equality. P1x plus P2y equals n. Okay, let's draw it. So we are having good x here, good y here, and let's try to plot this. Now if consumer consumes all of good x and none of y, then y becomes 0 and x becomes m by p1. The intercepts are m by p1 and m by p2. Okay, and this is the budget line. We denote it by BL. Okay, now let's see what is the slope of this budget line. We just derivated with respect to x. We get p1 plus p2 y dash equals 0. Money income is a constant number, and we get y dash equals minus of p1 by p2. Okay, the budget line is negatively sloped line, a linear line, linear function. Slope is minus p1 by p2. Okay, now another note of caution we would like to add here is that if the ICs downward sloping and convex, which is the case in Cobb-Douglas, plus convex, we apply the tangency condition. You would see it in more detail just after 2 or 3 minutes. Tangency condition. But if ICs are concave, we cannot apply the tangency condition. We cannot really apply the tangency condition. Now, why we cannot apply concave utility function, we would be seeing when we will study the concave function. But for now, you can just write here that in concave functions, we prefer extremes to averages. Extremes to averages. This is the primary reason for it. Okay, this is star point, so do take care of that. Now let us move to the optimal choice in Cobb-Douglas utility. Okay, Now first study it a little intuitively. Let's draw a budget line. Let's suppose this is the budget line and we have an IC. This is cutting this at 2 points. Okay, now this is the IC. Now we have to check that what is the maximum utility a consumer can derive with this IC and this budget line with given prices, money, income, of course. Now if the budget line, if the consumer moves somewhat more ahead, he can increase his utility. Okay, utility, the direction of utility increasing is upwards, as we have seen in the first class. Now again he can also increase utility further. Again he can increase, again he can increase until this point comes. The drawing may be a little messy, but you can understand. You can refer to Varian or Snyder for it, perfect diagrams. Okay, so this would be the point at which you can try the maximum utility given the budget line and the prices and the money income, of course. And this point is known as the tangency point. Okay, the tangency point. Now let us derive what are the tangency points for this, for the co-obligous utility. We already know MRS equals negative of alpha upon beta by y by x. Price ratio equals negative of P1 by P2. Okay, we equate the absolute values of this. This is the condition at which the IC and the budget line become tangent to each other. So let us solve for them. We get P1 by P2 equals alpha upon beta y by x. Now we either make it in the form of x or in the form of y. So here y comes to be P1 by P2 beta upon alpha into x. Now we substitute this value of y in the budget line, which we get as P1x plus P2y. Now we multiply P2 by this expression, we get P1 beta upon alpha x. RHS, we have the money income. Now we take x common. We get P1 plus P1 beta upon alpha into m. Now we make it do a bit of algebra here. We get P1 here, and we denote the equilibrium bundle. We write it as x star equals alpha upon alpha plus beta into m upon P1. Okay, similarly, when you solve for y with a similar kind of algebra, you will get y star equals beta upon alpha plus beta into m by P2. Alright, now what are these alpha upon alpha plus beta and beta upon alpha plus beta? These are basically the expenditure ratios, or the ratio in which money income of the consumer is being divided on good x and good y. How much expenditure making on x, how much on y. On x, the fraction alpha upon alpha plus beta is being spent, and on y, beta upon alpha plus beta is being spent. So these formulas, they make it very easy to check your answers, like are you getting the right answers or not. Okay, so do take care of that. Okay, so that was about a utility function, Cobb-Douglas utility. Okay, now moving forward, we can do a little bit of numerical problem, or let's move forward. You would be practicing some numerical problems towards the end of each topic once you get hold of a considerable amount of questions of topics. Okay, now let's talk about the next utility function, that is perfect complements. Okay, so next utility function we have is perfect complements. Now general form if we have to talk about is u equals minimum of ax comma by. Now first let's talk about what are exactly these perfect complements. Now these goods, these are two goods x comma y, these are two goods, these are consumed in a specific ratio. Now the word ratio is very important to identify which utility function the question would be talking about. Like for example, we need two pieces of shoes, with two pieces of socks. Okay, now we cannot say that we need two pieces of shoes with four pieces of socks. That's really not a normal kind of situation. We always need two pieces of shoes with two pieces of socks, or two slices of bread with one slice of cheese, with one slice of cheese. Alright, so these are some examples. You can or it might be the case that you always need four pieces of biscuits with a cup of coffee, So one thing is really common in all these cases, that is a specific ratio. You need two pieces of shoes with two pieces of socks, two slices of bread with one slice of cheese, four biscuits with one cup of coffee. Okay, so the word ratio, that should be very clear in your head. Now let us see how the indifference curve looks like in this case. Let's draw an indifference curve about it. Okay, the very first thing in a perfect complements question would be, you will have to draw the kink line, that is ax equals by line. Now it can be the case that it is x equals to y, that is a 45-degree line to the origin, or it might be the case that a greater than b or b less than a, that would be drawing here in this segment or in the above segment of this line as per the case. So this line would be, first of all, ax equals by. This is good y, we have the origin, this is good x. Okay, now let's try to think about it. Okay, the very first thing we need to understand is that we need a specific ratio. Like for example, let's say you get five pieces of socks. Okay, 5 pieces of socks, and you have 2 pieces of shoes. Now you use 2 pieces of socks with 2 shoes, and the rest remaining 3 pieces of socks that are of no use. Your utility is not increasing by consuming 5 socks, because you are only using 2 pieces of socks with 2 pieces of shoes. So your utility would not be increasing beyond consuming 2 shoes and 2 socks, with only socks being the excessive quantity good. Okay, so let us say here is 2 and here is 2. Okay, so you have 2 socks, you've got 2 socks, and you have got 2 shoes. That would be drawing a bit more nicely. Let's say Let's draw it like this. Let's say this is the point where we have 2x and 2y. Now let's suppose that for good y, good y consumption is increasing and good x is at this very point, that we have only 2 units of x, but good y, the quantity of good y is increasing. So we would be moving here, we would be moving here, we would be moving here. But notice one thing, that after consuming 2 units of x with 2 units of y, it is not mattering to the consumer, it is not beneficial to the consumer to have more of y unless he also has those many units of x also. Okay, so he is getting same utility on all these points. We are not increasing x, we are only increasing y. So all these points on this segment, these give us the same utility. Okay, these give us the same utility. Similarly, if we keep on increasing x but keep y constant, we will be moving in this direction and the utility would be constant, because these excessive units of x, these are not adding anything to the utility of the consumer, because he wants to consume x and y in a specific ratio, and that is why all these points also give the same utility, and therefore we have a L-shaped IC in perfect complements case. This is an IC. Okay, we can make many more L-shaped IC. Okay, now let us see what is the optimal choice in this case. What is the optimal choice in this case? If you are understanding and if you are liking the content of the video and the notes provided at the end of the class and a description box, do subscribe to the channel. So let's see now what is the optimal choice in perfect complements case. Okay, now up till now you must have understood that since we need a particular ratio, the optimal choice begins at the point where ax equals by, or we convert it into we convert y in terms of x, we got ax upon b equals to y. We similarly have the same budget line, p1x plus p2y equals m. If we substitute y here, we get p1x plus multiply p2 ax upon b into p2. We get this, and this implies x star equals, we add star for the optimality condition, m upon p1 plus p2 into, p2 into a by b. Similarly, we would be getting y star as m upon p1 into b by a plus p2 after a little bit of algebra which is being left for you to do. Okay, now what we will be understanding is bit of MRS conditions. Like, what is the MRS in this case? So first of all, we draw once again the ICs which are L-shaped. We draw the AX equals to BY line and we draw the ICs. Okay, so the optimality condition talks about this point, this very point where AX equals to BY, and this lies on the budget line also. Okay, this is the equilibrium condition. Now we can see, since this is the IC, at this segment the slope equals 0. So MRS is 0 at this segment, and at this segment the slope equals infinity. So this was all about perfect complements, utility condition, utility function, and these are demand functions x star and y star. Okay, now let us do the perfect substitutes, and the many more functions are there. So we will complete them in the upcoming classes, and you can find the notes for this class in the description of the box. You can also check out the economics in 60 seconds playlist, where I have covered a very fair few utility functions and their equilibrium bundles, and they are very helpful for quick revision. Thank you guys. Let's meet in the next class.